This is one of the problems from the homework. Go ahead. So what we need to do is we need to get all the x's on one side and all the other stuff on the other. Part of the challenge with this is that I've got a square root here and I got an x here, so I have x's on both sides. So the first thing I need to do is get rid of the square root. So the way that you undo a square root is you square it, and then whatever I do on one side I have to do to the other side. Now when you square a square root, because this is a square root, they kind of undo each other and you're just left with negative x minus 3 is equal to x plus 5 squared. So to do the x plus 5 squared, I'm going to come over here and I'm going to say x plus 5 times the quantity x plus 5. So x times x is x squared, 5 times x is a positive 5x, 5 times x is a positive 5x, and then 5 times 5 is 25. So this whole thing becomes x squared, we're going to combine like terms, plus 10x plus 25. So remember, I got to get all this stuff. This is a quadratic, so how do we solve a quadratic? Well, a quadratic is solved by doing this. Ax squared plus bx plus c equals 0. And then at some point, we get x plus or minus a number, we'll call it p, times x plus or minus a number, we'll call it q, equals 0, and then you set the factors equal to 0, right? So this is a bunch of stuff combined in one question. And then you get x equals p or q or whatever. So in other words, I need to move this stuff over. So what I'm going to do is I'm going to add x to this side and I'm going to add x to this side. These will cancel and I got negative 3 equals x squared plus 11x plus 25. Then I'm going to add 3 to both sides because I want to set it equal to 0. And I get 0 is equal to x squared plus 11x plus 28. So now to factor this, I need to think to myself, I'm going to take the first term and the last term. So I'm going to draw the grid. The first term is x squared. The last term is a positive 28. Let me draw that a little nicer. X squared plus 2, 8. Well, x times x gives me x squared. Think of two numbers that I multiply together. They give me 28, but also keep in mind that whatever I have in here and here has to add up to here. Well, positive 7 and positive 4, when you multiply them, they equal 28, right? But also, what's 7 times x? 7x. What's 4 times x? 4x. What's 7x plus 4x? 11x. So this thing factors to x plus 7 times x plus 4. X plus 7 times x plus 4. So now the next step is I'm going to set both these factors equal to 0. X plus 7 equals 0 and x plus 4 equals 0. Subtract 7 over here from both sides. I get x equals negative 7. And then if I subtract 4 from both sides over here, I get x equals negative 4. those are my two answers. This and this. Yes?
So which one do we plug in? Because we only have to put in one x.
Ah, so that's a good question. So I'm not quite done yet. The question was, we only have an option to plug in one. Now what do we got to double check? What are some domain restrictions? Well, the only domain restriction that I see, so this is why we've been asking all these questions about domains. We can't take the square root of a negative number, correct? So way up here, I've got the square root of negative x minus 3. Now one of these numbers will make that negative. Which one do you think it'll be? One of them will make it positive. So let's try it. If I say negative x, which is negative 7, minus 3, this becomes a positive, and so we end up with the square root of 7 minus 3, which is 4, which is just 2. So this one works. This one checks out. This one's okay. But now let's try the other one. If I take the square root of negative, but for x, I'm going to plug in negative 4 minus 3. Actually, they both work. This becomes plus 4. And then that equals the square root of 1, which equals 1. That's an interesting one. Well, it looks like they both work. But you're supposed to check it. So I suspect, let me just double check real quick.